Hello everyone, welcome to our video on mixture separation techniques. Now, first of all, we need to know the difference between a heterogeneous or homogeneous mixture. A homogeneous mixture is a mixture that appears to be all the same material. So the picture that we have here is chocolate milk. We know that we add syrup to regular milk, but there's no chemical reactions going on there. They're just dissolving, which is a physical change, which means that they're mixed together. It looks like everything is the same, but it's not. Heterogeneous is a mixture that is clearly composed of different materials. So an example we have here is trail mix, right? You can easily pick out the M&Ms, the different nuts, raisins, whatever you have in there, and you can easily tell that it's a mixture. Now here's some of the separation techniques that we're going to talk about today. This is by no means an exhaustive list. There are plenty of other ways that things can be separated, but these are the really big ones that we're going to talk about today. So the way that we separate things is we use physical properties to separate them. Sometimes we separate them by color. We can separate them by size, shape, density, solubility, melting point. And, it's not always practical necessarily to just, if you have, your trail mix, for example, you can easily pick it out with your hands, but it's not always practical to do that. So here are some ways that you can more practically separate some mixtures. So you could just use a magnet. Some materials are magnetic and others are not. If you have iron filings in sand, sand is not magnetic, but iron filings are. Grab your magnet, run it over the mixture, and you'll pull your iron filings right out. Decanting. This one's a little bit tricky sometimes depending on the actual material, but decanting is if you have something solid and you have something liquid, you carefully pour off that liquid so just the solid is left. Now there may be some liquid left, so if it's something like water, you may have to let it dry, but you should be able to get the majority of the liquid separate from the solid just by very carefully pouring it off. Next is filtration. If you have things that are a bunch of different sizes, for example, you have sand and you have gravel, if you get a screen that is a big enough holes for the sand to go through, but too small for the gravel to go through, you just go ahead and shake that through the screen and the gravel will be left on top and the sand will pass through on the bottom and you're separated. Evaporation is another technique. If you dissolve one substance in water, decant it off, and then evaporate the water, you can get that back. For instance, salt very easily dissolves in water. Sugar does as well, and that's actually the method that you use to make rock candy. If you have, let's say, a salt and sand mixture, I'm going to use sand a lot, you can add water, dissolve your salt, decant it off, and then evaporate the water. You're left with just good old sand on the one side and good old salt on the other. A centrifuge. Now, mixing gives you a lot of the same effect here, but a centrifuge is a special machine that basically spins materials for you. And what the spinning the materials does is it separates them based on density. So you see on the left there we have a bunch of different liquids, and then at the top we have stuff that's all different sizes and densities. We spin it through the centrifuge. The things that are the most dense will move to the bottom. Things that are the least dense move to the top. This is used a lot in the medical field in particular. Chromatography. Chromatography helps you separate materials based on how well they travel in water. This is commonly used for any kinds of inks or dyes, and actually in order to basically create a new pen, you have to have a unique chromatography signature. So you can see in the pictures there that the blues tend to rise, the pink tends to kind of go all over the place, and the yellow kind of runs down but stays more in the middle. So the different colors will actually travel different distances based on if you have water run through them. Distillation. Now this one's a little funky, and you probably won't see it until high school, but you can actually separate liquids based on different boiling points. If you have two things, for example, let's say something boils at 50 degrees Celsius, and it's also mixed with water, both liquids, and water boils at 100 degrees Celsius. If you get that mixture to 50 degrees Celsius, the first liquid will boil, and then it'll, become vapor, go up into the air. You can condense it and have it run off, and then you have that pure liquid. And then since it did not heat the water high enough for it to boil, it won't turn into a gas. So it'll just stay in the original container. So again, you probably won't see this until at least high school, but it is one of the ways that we can use to separate materials, particularly liquids. And electrolysis. This is actually the only one that we're talking about today that can separate things chemically, but you can actually run electricity. Basically, it's a little bit more complicated than this, but essentially you can use electricity to separate bonded elements and get them back into their pure element form. So just in general, to separate mixtures, you need to figure out what the materials have different properties for. So for example, is one magnetic, is one not? Are their boiling points very different? Do they travel differently in water? All of those different things. And use those differences to your advantage. Use those differences to separate your mixture. Sometimes, especially if you have more than two things that are mixed together, you might need to use multiple techniques. Maybe you have iron filings, salt, and sand. So you need to, get the salt dissolved in water, decant it off, evaporate, you got the salt, but still you got the sand and the iron filings. So then you take your magnet and run that over and get those out. So could use multiple techniques if it is more than one thing, more than two things. But as long as you figure out what those differences in properties are, you can pretty much separate anything you want to. All right, that's all for today. Have a great day, everyone.